Today, let's talk about the most noteworthy product from OpenAI's 12-day Christmas release event, which might also be the strongest reasoning model so far, the upgraded version of O1 called O3. In September this year, after OpenAI released the O1 model, it seemed to open the door to reasoning models. Subsequently, many domestic and international large model companies launched a variety of reasoning models. Due to the potential conflict with the name of the British telecom operator O2, OpenAI decided to rename the model from O1 to O3. Like the previous O1 model, O3 also uses a chain of thought to reason, gradually explaining the logical process to summarize the most accurate answer. Additionally, this time, O3 comes in both a full version and a mini version. A new feature allows you to set the reasoning time of the model to low, medium, or high modes. Of course, the longer the model thinks, the better the results. The mini version is more streamlined and fine-tuned for specific tasks. It will be released at the end of January, while the full version of O3 will be available shortly after. One of the most eye-catching aspects of O3 is its performance in the AR-CAGI benchmark test. AR-CAGI is a benchmark test used to evaluate the AI system's ability to tackle extremely difficult mathematical and logical problems that it encounters during reasoning. It was proposed by François Chollet, the father of Keras, in his 2019 paper on the evaluation of intelligence. This benchmark has been out for 5 years but has yet to be cracked. Let's look at a specific example to understand it better. In problems like this, AI needs to find a pattern based on paired input-output examples and then predict the output based on a given input. In the ARC-AGI test, O3 has already reached an excellent level, becoming the first AI model to break through the ARC-AGI benchmark. Specifically, O3 achieved a score of 87.5% in high-efficiency reasoning mode. In low-efficiency reasoning mode, it scored 3 times higher than O1. To put this in perspective, GPT-3 scored 0%, GPT-4 scored 2%, and GPT-4.0 scored 5%. Even O1's Pro mode only reached around 50%, but O3 boosted the score to an impressive 87.5%, which is truly eye-catching. Compared to earlier large models, O3 is capable of handling tasks it has never encountered before, reaching a level that is close to human intelligence. François Chollet also released the full test report for O3. The model was tested on 2 ARC-AGI datasets and evaluated at 2 computational levels with variable sample sizes. One was a high-efficiency test with 6 samples, and the other was a low-efficiency test with 1,024 samples, which is 172 times more computationally intensive. In the results, 75.7% of the high-efficiency scores were within the $10,000 budget rule of ARC-AGI Pub, while the 87.5% low-efficiency score came at a high cost. However, the test results still indicate that performance improves as computational load increases. The report also notes that ARC-AGI is not a strict test for AGI. Passing the ARC-AGI test does not equate to achieving AGI. Chollet also stated that he believes O3 is not yet AGI. It still fails at some very simple tasks, which shows it fundamentally differs from human intelligence. He also speculated on how the O3 model works. The core mechanism of O3 seems to involve searching and executing natural language programs in token space. During testing, the model searches through a potential chain of thought space, which describes the steps required to solve the task. This approach might be similar to AlphaZero style Monte Carlo tree search MCTS. In fact, O3 may be guided by some deep learning models that lead the search process. It is worth noting that DeepMind's Demis Hassabis hinted in a June 2023 interview that DeepMind has been researching this concept for a long time. Currently, the use of the O3 model is not very economical. Users need to spend about $5 per task. In the low-efficiency reasoning mode, O3 takes about $17 to $20 to complete each task. Next year, OpenAI will collaborate with the foundation behind ARC-AGI to build the next generation of benchmark tests. Based on early data, the upcoming ARC-AGI 2 benchmark will still pose a significant challenge to O3. Even under high computational load, O3's score may drop below 30%. In contrast, a human without any training can still score over 95%. However, in other benchmark tests, O3 far exceeds its competitors. In the SWE Bench Verified benchmark, which consists of real-world software tasks, O3's accuracy is about 71.7%, more than 20% higher than O1. In the programming competition Code Forces, O1 scores 1,891, while O3 in low-efficiency reasoning mode has already surpassed O1. In high-efficiency mode, its score can even reach 2,727. This score corresponds to an IQ of about 157. If we consider that Einstein's IQ was generally believed to be above 160, he would be one of the few who could challenge AI. In fact, we should focus more on the speed of improvement. When OpenAI released GPT-4o earlier this year, its IQ was only 115, within the range of a normal person. The preview version of O1 reached 123, equivalent to a PhD level. The full version of O1 reached an impressive 135. O3 Mini broke the 140 barrier. This means OpenAI increased AI's IQ by 42 points in just 7 months. According to the Flynn effect, which suggests that IQ test results tend to increase year by year, humans would need about 140 years to increase their IQ by 42 points. Looking at the Code Forces leaderboard, O3's score ranks 175th, surpassing 99.8% of programmers worldwide. In the AIME 2024 Mathematics Benchmark Test, O3 achieved an impressive accuracy rate of 96.7%, missing only one question. In comparison, O1 had an accuracy rate of 83.3%, while GPT-4o only reached 13.4%. In the stringent GPQA Diamond benchmark, which measures doctoral-level scientific questions, O3 achieved an accuracy rate of 87.7%, about 10% higher than O1's 78%. Professional PhDs typically score around 70% in their areas of expertise. Additionally, O3 set a new record in the Epic AI Frontier Math Benchmark, considered the strongest math benchmark in the industry, co-developed by over 60 global mathematicians, including Terence Tao. O3 scored 25.2%, while other models didn't even surpass 2%. In comparison, O3 Mini is a more cost-efficient version of O3. It focuses on improving reasoning speed and reducing reasoning costs while maintaining model performance. Through the adaptive thinking time mechanism, O3 Mini can automatically adjust the depth of reasoning based on task difficulty. It offers 3 reasoning intensity options: low, medium, and high. Compared to O1, O3 Mini shows significant cost effectiveness on Code Forces. For example, in medium intensity mode, O3 Mini outperforms the full version of O1. Although O3 Mini High still lags behind O3 in high-intensity mode, the difference is minimal. Apart from impressive coding results in the AIME 2024 Mathematics Competition Test, O3 Mini Low already approaches the level of O1 Mini, while O3 Mini Medium surpasses O1 with an accuracy rate of 78.2%. O3 Mini High further improves performance. In terms of latency, O3 Mini Low significantly reduces latency to under 1 second, comparable to GPT-4's instant response. O3 Mini Medium is twice as fast as O1 Mini in terms of latency. To meet developers' needs, O3 Mini also offers a complete set of API functionalities, including function calls, structured outputs, and developer messages. Remarkably, in these features, O3 Mini not only matches O1, but also performs better in most evaluations. In the GPQA dataset test, O3 Mini also demonstrated stable performance. Even in low-intensity mode, O3 Mini Low achieved an accuracy rate of 62%, also gave a live demonstration of using O3 Mini to generate and execute Python code. In just over 30 seconds, O3 Mini wrote its own ChatGPT UI, which allowed it to send requests to call an API and converse with itself. Then it used this UI to write and execute a script to evaluate its performance on GPQA. The result was that the script correctly returned 61.62%, which was close to the formal evaluation result. Despite being a low-intensity model, it ran extremely fast, completing the entire evaluation process in just 1 minute. Although the O3 series models will not be immediately released, OpenAI has already started granting access to O3 for security researchers, with the application deadline set for January 10th. On its official blog, OpenAI also revealed more technical details about the new alignment strategy used in O3. We will briefly introduce it here. As we know, modern large language models generally use supervised fine-tuning and reinforcement learning from human feedback for safety training. However, there are still many security flaws. OpenAI researchers believe that many of these failures are caused by two limitations. One, the model must respond immediately to user requests, which does not allow enough time to reason through complex and edge security scenarios. Two, large models must infer the desired behavior from a large amount of labeled data rather than directly learning basic security standards in natural language. This forces the model to reverse engineer ideal behavior from examples, leading to poor data efficiency and decision boundaries. Based on this, OpenAI introduced a new training method called deliberative alignment. It combines process and outcome-based supervision, allowing large models to reason through complex safety norms explicitly before generating answers, thus overcoming the two previously mentioned issues. In contrast, other strategies that optimize responses during reasoning will limit the model to predefined reasoning paths and do not involve direct reasoning of learned safety norms. Let's take a look at the specific steps of deliberative alignment. First, researchers will train a model specifically for the O-series without any safety-related datasets. Then, they will construct a dataset containing pairs of prompts and completions where the completions reference thought chains and insert relevant safety norms into the system prompts for each conversation. The model will then be trained on this dataset by removing the system prompts. Next, the dataset will undergo incremental supervised fine-tuning, allowing the model to learn the content of the safety norms and how to generate consistent responses through reasoning. Finally, reinforcement learning will be used to train the model to use thought chains more effectively, introducing a reward model that provides additional reward signals by accessing safety policies. This strategy will be carried out in two core stages. 1. In the first stage, supervised fine-tuning will teach the model to directly reason about safety norms in thought chains by using examples that reference the norms in the thought chains. 2. In the second stage, researchers will use high computation reinforcement learning to train the model to think more effectively, introducing a larger model to serve as a referee that provides reward signals based on the specified safety norms. It is worth noting that OpenAI's training program does not require human annotations and relies only on the data generated by the model to ensure precise compliance with the norms. This solves the challenge of large-scale manual annotations required in traditional large model safety training. As a result, researchers compared the safety of O1 with GPT-4o, Claude 3.5 Sonnet, and Gemini 1.5 Pro across a series of internal and external safety benchmarks. It can be seen that O1 passed some difficult safety assessments and achieved a Pareto improvement in areas like rejection insufficiency. Regarding deliberative alignment, the Anthropic team recently had a podcast interview. If we have the chance, we'll make a detailed video about it in the future. That's all for the basic introduction to O3 and O3 Mini. Since they haven't been released yet, the specifics of their use will have to wait until next year when they are officially made public for testing. However, just before the release of O3, Alec Radford, the main author of OpenAI's GPT series papers, announced his departure and will transition to independent research. Recently, media outlets disclosed that the development of GPT-5 has been stalled for 10 months. It's still unclear whether O3 will face delays, but at least for now, the global race toward AGI continues to accelerate.